Hey guys, the CNC is up, homed, and making clean chips. XYZ are dialed, motion is tight, and the sound is exactly what I want. In this one, I'll walk through how I wired the motors, set up the optical endstops and probe, and got the control stack running with Klipper Mainsail in a Docker container on Windows. Quick thanks to JLCMC for sponsoring this video. They've got global delivery, competitive prices, and $70 in new user coupons, link at the top of the description. Their site is easy to navigate, and it was simple to find exactly what I needed, like the KK60 rails and aluminum frame parts, plus the 3D models that helped me plan the design. Makes the whole process way easier. Before we dive in, wiring isn't flashy, but it's critical. Do it right the first time, or the debugging later will cost you way more time. Label your cables, double check polarity, and give everything strain relief. Test every connection with a meter, even if you're 100% sure it's correct. A quick continuity check now saves hours of chasing failures later. The way Axis has 2 motors, wired in parallel to one driver. I don't plug the wires straight into the SKR Mini first. I crimp the pins onto the wires, then insert them into a 4-pin HSG header. That header clicks onto the SKR Mini E3 mainboard. I used to do these crimps with basic pliers. It works, like in my older PNP video, but the dedicated crimper makes it fast, solid, and neat. Now the Spindle power supply. I cut the end of PC power supply cord and used it to power the Spindle power supply. We connect live, neutral, and earth to the 3 AC terminals. Unplug the cable first and be careful here. This carries high current and can be lethal. After the wires are connected securely, I power the supply and test the motor lead polarity with a meter to make sure the spindle runs in the correct direction. Milling bits are directional. I also test the potentiometer. The current setting to the motor should be between 0 and 100 on this scale. Mine reads 110 max, which is okay. We added waggle connectors at the end of the motor cables to make the motor easy to disconnect and reconnect. We will also replace the potentiometer with an adapter that converts the PWM signal from the SKR Mini to 0 to 10 volts, so the spindle speed can be software controlled. First, I prep the cables. I crimp the pins on each sensor lead and snap them into HSG 2-pin headers, one per sensor for X, Y, and Z. The white wire isn't used, so I fold it back and heat shrink it for isolation. The brown wire stays parked for now. We'll come back to it later. Now we hook everything to the mainboard. Stepper motors go in first. I'll label your cables. It's really easy to mix them up. Keep watching, you'll see me make a cable mistake and fix it. To flash the firmware, I power the board over USB. I place the jumper on the board's power select pins so USB can feed it, flash Klipper, then remove the jumper so the board goes back to its normal power path. Now the brown wires, these need 5 volts to power the optical sensors. I bring the brown leads together and feed them from the E-stop 3-pin headers 5 volts on the SKR Mini E3. For the Z-probe, I'm using PC14 and G and D on the 5-pin header. The 2 extra pins on that header are reserved for the PWM control we'll use to run the spindle from Mainsail, and that's coming in the next video. Now I connect all the cables to the motors, and this is where labeling pays off. These linear rails include a smart bracket designed for the optical sensors. I really like how they're made. Easy to place, easy to slide for fine adjustment, and they lock down solid once the trip point is right. This cable setup is temporary. I'll add cable chains to guide and protect everything. For now, I'm doing my best to route cables away from all moving parts, but this is not the final safe solution. Now a little about software. I'm running Klipper Moonraker Mainsail fully in Docker on Windows using WSL2. The board is passed through by its /dev/serial/by-id path, and Klipper and Moonraker share the same /opt/printer data, so configs live in one place. Mainsail is at localhost port 8999. Moonraker is at localhost port 7126. To start the stack, I just run docker compose in the project folder. If the board doesn't show up, I reattach it with USB IPD and it's back. I'll put the full folder structure on my GitHub soon, so you can drop it in and go. Why containers, you may ask? Because it makes the setup portable and predictable. I can move this CNC to any PC, shop computer, or laptop by copying one project folder and running a single command. No driver hunts, no broken paths, and all configs stay together. If the board drops, I reattach it with USB IPD, restart with docker compose up-d, and I'm back online in seconds. To secure my test piece, I mounted an aluminum T-track under the CNC frame and fixed it with T-slot fasteners and M5 bolts. For the MDF board I'm using as the test workpiece, I'm clamping it with 2 quick-acting T-track hold-down clamps. That's enough for this test. Now I home the machine, move the spindle over the workpiece, and 0, X, and Y. Then I probe Z, load my G-code, and hit run. Voila, a working CNC. Big thanks to JLCMC for sponsoring this video. Their steel linear rails are really well made. Next video, I'll improve the CNC, add cable chains, print enclosures for the mainboard and the power supply, and try a wireless control idea from my phone. Thanks for watching. Please like, subscribe, and leave a comment if you have questions or recommendations. See you in the next video.